going to show you the method I use for putting in a barb connector. So we're short on pipe. This is the barb connector there. We're short on pipe, so I'm having to scab a couple of pieces until I can get a full length in. And this is how I do it. I just heat up the pipe. I don't want to heat it up too much. I just want it to where it's soft. Heat up the other end. Okay, as soon as I can start deflecting the pipe, I think I'm good. This time we're using just simple gear clamps. I use 2 on each joint. So I oppose the gear mechanism, so they're opposite. So when they tighten, they tend to pull from this area here more than maybe the static area. So if they oppose, then I don't know. There's an idea that you get a better connection. So I just hand tighten them. I make sure that they sit on the actual barb itself. I'll show you in a second. So I sit them at 180 degrees from each other, and I don't want them sitting in this area. The pipe's not flexible enough to kink into this area. We always get leaks, so I try to sit them on the barbs itself. And 2 more, make sure they're opposing, slide them on. This is the hard part, not that hard. The raven in the background there. Letting everyone know I'm up here, I guess. Okay, once that's at this point, I then just want to tighten it up a wee bit more. I don't want the clamp, this is a feel thing, I don't want the clamp, you know, these are easy to break the, I guess, I don't know what that is, the step between the metal. So you kind of got to be careful when you're tightening them. Okay, that's it. On to the next one. So like I say, I'm scabbing together pipe here, and one of the cheaper joins, just with gear clamps. We're about, I would say, well, we're 350 feet up from the turbine in pipe length, and I would say we're getting close to maybe 120 feet in elevation. So we've just got to get, those are the water tanks you can see in the background. We've just got to get these 2 pieces here joined up, and then we'll be at the T-valve. Alright, so this is our T-valve. We're up above, again, up above the house by quite a bit, and certainly up above the turbines. So here I don't know what the pressure would be, but we could work it out. So we've got 2 valves. We've got our valve to the heating turbine and the valve to our power turbine. Okay, we're at just over 80 psi, maybe 82 or something. What I'm going to do now is just bleed there'll be air in the pipe. I'm just going to let that flow. Make sure my turbine valves are shut, and just bleed out any air from the system. Just going to open my valve. I don't want it to drop too much. Because we want the other turbine to keep running. And if I open this up fully, I think it'll drop the pressure over on that one completely. So as soon as we hear it here, bubbles stop. So I'll follow you. That's what we are taking for the other pipe. We've got a static pressure of 80 psi, no leaks anywhere. I do have one here, which I will get to. I need to tighten that up a little bit. And I always find that when you get two dissimilar materials meeting, there's often issues. Like when it's metal on metal, I never have a problem. When it's ABS and ABS, I never have a problem. Just when it's like whatever this is to ABS or that to metal. Anyway, let's get it up and going. Watch our amp meter here. We should. We can't open it wide open. It's going to take a while for all the bearings to wear in, but I find that it'll generate pretty slowly at first, and then over time, as it gets worn in, it gets faster and faster, more efficient. So right now we're looking at about 5 amps, but I'd expect that to go up quite a bit when we open up the when it wears in, I guess. So we've dropped down to 62 psi. So this one here is using 20 psi of force. It's dissipating 20 psi. You want to see how much water it's using at the outflow. Yeah, so it's using a bit. Again, I've got to run a pipe down. An exit and outflow pipe. So that's using a pretty significant amount of water. I'm surprised. It's more water than I thought. Okay, so now we'll just go check the dump. Okay, with the other turbine off, we've got almost 95 psi, and let's see, we'll open this up, and bearing in mind that this is all the bearings are brand new and are not worn in at all, so there's a wear-in period for these. I find that after 24 hours your output is, I think, probably like 10-15% more, something like that. Anyway, what have we got now? Right now 12 amps, that's 600 watts. Just purely heat. So we'll go and have a look at what that translates into at the dump in a second. Alright, seems fine. It'll be reasonably quiet once we get the door on. Okay, so the house this is a totally off-grid house. We get deliveries for propane, but that's it. Okay, our crawl space. The idea of this is that this is our dump here. Maybe I can turn on a bit more light. This is our dump, which I showed you before. Oh yeah, it's getting hot. It's not hot, but yeah, it's going to get pretty warm. So our cables, you probably can't see them, but anyway, our cables are low, the elements are high. Yeah, well, that's doing something, definitely. So that's the idea of it. Once we iron out the efficiencies, I think we should be getting 1,000 watts out of it. 1,000 watts just for heat. And the idea is that over here, you can't see it very well because it's dark, but over here we'll have a return air so the furnace can start moving this warm air. This will be a fully sealed basement, of course, you know, it'll have membrane over it. And so no exposure to the earth, the damp earth here. But yeah, that's the house. Alright, so she's pretty rough right now, but basically there'll be a pond here and an outflow that'll take right to the ocean. So I'll just bury in this pipe eventually over the road that runs between our two properties, and I'll dig this out and make a frog pond, which is what I'm pretty excited about. Frog pond would be nice, but I feel like this has got to be quite a bit bigger than what it is. And I'll line it too because I want the water to stay. This water will just disappear. It's all rock up here, so things disappear pretty quickly. But yeah, got a bit of an outfall. It's rough, but it's working. Okay, let's go look at the turbine and see what our production is at. At 48 volts, roughly 850 minus 17, we're about 800, just over 800, 810 watts, something like that. PSI is at 90, so it's looking pretty good. It's noisy, so I totally can appreciate now the work I've done in quietening it down. Let's go and have a look at the dump, see what we got going on. Yeah, I can feel some heat here already. Oh yeah, there's some heat for sure. I'll bring in my, oh yeah, I can't really touch that anymore, so which is great. I mean, it's not going to burn me, but it's warm.